How's it going, guys? Matt here with Code Tech Tutorials. We're going to do a video on ChatGPT now. I'm sure you guys have seen all you wanted to see about this at this point. Every YouTuber and their mom and their dad and their brother and sister and their past relatives and everyone from their history has made a video on this because it's easy clickbait. And the consensus seems to be that it's basically Google, maybe a little bit better, and it can also write papers for you, so you don't have to do your schoolwork, and that further diminishes the point of school, I guess, if you don't actually have to do the work while you're going, because you're there to learn by doing the work. Why make something that does the work for you? And except, anyway, that's a whole nother ball game. But yeah, I basically want to see if it can actually help me solve real problems that I have. Obviously, if you ask it some common question that's in an interview, it generally knows the answer to those because it can Google them and figure it out. And if you ask it for some very common thing to do with code, it can generally Google that and figure it out. Well, I'm saying Google. I don't know how it actually does behind the scenes, but basically, if the answer's somewhere out there on the internet, ChatGPT seems to know about that answer and can kind of word it to you like a human. That's basically what I've taken away so far. But here I am. I'm working on my little game here, game library stuff, and one of the things I'm doing right now is I'm trying to cook height fields with NVidia PhysX 4.2. So that's kind of a big side point, but I'm wondering, because this is sort of a difficult thing to wrap your head around and do. I've got it like half done at this point, but I was wondering, can GPT maybe help me? Because NVIDIA documentation's there and there's some samples and they're decent and they kind of get it done, but they don't really get it done quite right. I have to abstract some things and figure out some stuff, and let's just see. All right, so let's see. Let's ask it, put it full screen. How do you cook let's see, a model mesh in C++ with NVIDIA PhysX? Let's see what it comes up with here. All right, to cook, okay, it goes pretty quick. Create a cooking. Oh, wow, not bad. Create a cooking object called, yeah. Wow, I found this answer quick. But this is basically the answer from the documentation, so I'm not surprised, and this is probably somewhat common answer. All right, so we get cooking. It has kind of skipped over one thing I know already. But yeah, this is basically the very, very much the default answer, but are also not bad, not bad. This is kind of what I would expect to see. It's actually, this was way easier than finding this on Google, and this was very quick. So basically on Google, I had to sort through like tons of nonsense stuff to find this. Not tons, but a few things. It wasn't quite this easy, so this is very nice to just see this. All right, so let's read it from the top. To cook a model in C++, you need to use the physics cooking library. Here's a high-level overview. Now, you do have to, I believe, initialize physics in the physics and some of its common stuff like the foundation. So it skips over that, but maybe it assumes you know that already. I don't know. But that's not too bad. So create a cooking object with the px create cooking. This is correct. Yes, definitely. But I'm pretty sure you got to do the foundation first. All right, we'll come back to that. So maybe, they're getting us on the right path, but we do have to maybe do a little bit of digging to know for sure whether this will work. But it has skipped right to the cooking, which is what I asked. All right, load the mesh data from a file or create it programmatically. The mesh data should be in a format that is supported by the physics cooking library, such as triangle mesh or convex hull. Okay, not bad. I think I'm using triangle mesh for the most part, and use the cooking object to cook the mesh data. This process converts a mesh into a form that can be used by the physics engine. Yes. Attach it to a rigid body. Let's see, it does do that in here. We'll get to that. Okay, use the cooked mesh data to create a physics shape, triangle geometry, or convex mesh geometry attached to a rigid body. Optionally, you can use the cooked mesh to create a visual mesh for rendering purposes. All right, here's an example. Let's see, mesh description. You fill the mesh description with your vertex and input data. Very good. Yep. All right. So this is pretty good. See, I think that this is going to be a pretty good aid to programmers as far as getting stuff done, because often one of the big roadblocks for people is just finding information that's correct enough. Like when you're digging through documentation, you're always finding, I don't know, if you're Googling problems, you're always finding like these 12-year-old Stack Overflow answers that are just completely riddled with nonsense that doesn't help you. I don't know if you guys had that problem, but I had that problem. It's like the top answers are always 11, 12 years old, at least, it seems like. I don't know why that is exactly. I don't know why Google would put things that old at the top of their results, but it does it all the time for C++ stuff, and it's kind of frustrating. And it's obviously useless data. Things have changed. Most of the answers on those are not very accurate, and you really got to like figure out a bunch more. But okay, this is basically correct though. It did skip over initializing physics. I think that's the big thing it missed here. But hey, let's try this. Let's just copy this code. Boom, copied. And let's go to this. I got this little cooking main. So first we got to do some stuff. We can assume we need to create all this stuff. So we could just do it. I'm just going to do it in the main. I think I'm just going to do it. Well, the tricky part, there's a lot of tricky parts to this, we'll say. It doesn't tell you how to link the library or set it up, but you could probably ask it that. I've already done it in the CMake, but let's just ask it. Let's go. Let's say, how do you link physics 4.2 with VCPKG and CMake on Windows? Let's see if it comes up with an answer. Install VCPKG, very good. Yep. Install the physics package, very good. Yep. Add the following lines to your CMake. Include path that CMake, find package, physics required, target link libraries, private physics. I wish this were the case. It's not quite right. And compile definitions, build your project. Okay. So the problem is this doesn't work at all. There is this is completely like, I don't know, unless they've updated it very recently, this find package physics doesn't work, at least in my experience. Let me try it, actually. Let's just try it. All right, so I'm doing it locally. I'm doing it a little differently. This is for like globally on your system. So the only way I could find to do it was, well, yeah, you got to put it in your VCPKG JSON. This is for doing it locally with your project. The install way that they showed was globally. That's fine, actually. But you can't just find package physics. You got to do find library with these hints for every single different one. So that's a big difference. But I don't know. Let's try it. Let's go. Let's try this find physics required and target link library and get rid of all of these and see if it's happy with that, because I didn't find that to work. So yeah, let me just link a target here like this one here. And we'll get rid of all of these. Okay, so let's try it their way with find package and target link libraries and see what happens. Nope, can't find it. So yeah, this is what I ran into as well. So now to play the other side, they did install it differently. They're not doing it with this project-based mode. Like this installs it specifically for this project, not globally. So maybe that's a little bit different. Do we need to put config in here? Will that make a difference? No. But ultimately, yeah, this is what I ran into. I thought what they said would be accurate because that's what it seemed to be. But that it might be close. I'd have to try it the global way. But in general, no, that didn't work. I had to do it this other way, which does work. And I had to. There was no answer to this. Like you can't find this online. This answer right here of how I had to do it is nowhere out there. You basically have to understand how find library works, and yeah, you basically have to understand how find library works and deduce the answer yourself. So that was the reality of it for me here. So it does kind of make sense to install such a large library like physics, generally pretty large globally. With VCPKG, and that's generally the more accepted way of doing it, is to do it globally, not project-based. But I just like doing it project-based. I think it's better for shipping the end product. But also, your results may vary. It's just the way I like it. So we'll say not bad. Let's go back to that. But not bad, not bad. If you're using it, it even gives you more of this add compile definitions for PX, C++11 or 14, and the physics library should be linked with your project. Okay, so that's not bad. Yeah, link to VCPKG's toolchain file. So if we do all of this and we install it globally, I would kind of expect this to work, but not bad. Let's see. Let's ask the same question. How do you link let's see, same question, but we're going to add to it as a manifest. Now, the manifest, okay. I don't know. Okay, I guess we got to start over. But new chat, boom, as a manifest. Let's see. Okay, I don't know. It's broke. So does this happen to everybody? Okay. Okay, it's going to give us the same answer, I think. Let's see if it shows as a manifest. No, this is not as a manifest. This is globally. Slightly different answer. They gave the x64 and x86, and they put some generator stuff in there. And this time their find package has config on it for some reason. So a little bit of different stuff. But that's not with a manifest, because the manifest is this JSON right here. So they should say that you have to create this file and add physics to the dependencies. That's what they should be telling. So they're getting close here, but if it's anything like I experienced from Googling this same question, basically this doesn't quite work because this find package doesn't work. It'll just keep giving you the I can't find it, and you got to come up with your own solution, which ends up being this find library. So while I'm finding this is very interesting, overall I'm finding that I'm running into the same problem I had with Google, and that's just basically that nobody actually has the answer out there. So this thing doesn't have the answer out there either. I don't know. Pretty interesting, I guess. Let's try something else. Let's say, all right, so one of the ways I'm still messing with this, let's say I'm trying to get the vertices and indices from a mesh out of ASIMP and pass them into physics for baking. All right, so what if we go get the vertices and indices of a model or of a model file, there's say 3D model file, into C++ code. Let's see what it says here. Comes up with an answer pretty quick. Use 3D modeling software, export it. Okay, that's cool. Yeah, it's so far so good. It says use tiny object loader. That's good. Or use SIMP. Okay, not bad. Okay, and then it tells you to use like OpenGL or DirectX. Okay, a pretty good general answer actually for that quick question. You know, that's generally the steps you would follow. All right. That's also probably about the same thing you'd get with Google if you ask the same question on Google. So I don't know, but I think you guys probably get the point. At this point, it's pretty good, but it runs into somewhat the same problems that you have when you Google the stuff. Whereas when it doesn't quite work, where you like follow the steps exactly, and then you still get there's no package or whatever on this step, you like, how do you know what to do next? You don't, and it's going to be really hard to find it. And basically, it's not gonna do this find library thing. Um, yeah, I'll come up with some more stuff to ask you here shortly. I'm gonna do some coding, and I'll pop in and ask this some questions here and there. Now, I do like that it saves on your account the previous chats you've had, so you can go peruse over your answers. This is way better than, like, I don't know. For me, I usually have a bunch of tabs open after a while with somewhat links to my different questions and stuff. So it's nice to be able to just pop over here and be like, oh, what they say? I can just go look real quick. So that's nice. Okay, it didn't really seem to, it told us how to initialize the cooking stuff here, but obviously this doesn't work completely. We need to fill out some stuff, like we need to initialize physics foundation and that kind of stuff. So maybe we can ask it how to do that. How to initialize physics. How to initialize physics 4.2. Yeah, we need the foundation object. Okay, then create physics. This has given us a CUDA context manager and some basic tolerance scales. It's got a use CUDA boolean optional. All right, let's just pop this in here and see what happens. Now, do we want to use the CUDA stuff? Also, why is this include not working? I think we gotta regenerate some stuff here. I know some of you guys are gonna complain about my coding environment being white, but I find if I make it dark, I can't focus as well. Like, I just focus better with the light background, at least during the day. At night, I like to turn it back to dark. But during the day, when the sun's shining, I'm in a bright room, it's so much better when it's light. But it's getting late, so I'm ready to turn it to dark anyway. So actually, I switch this quite frequently. During the day, light background. All right, cannot open source file. Well, it should be able to here shortly once we get this thing finished. All right, but I have a feeling that this is generally going to be how it goes for most stuff. Like, you can get a good sample of what the code might look like, but it's only like a starting point. So you're still going to have to figure out, like, what do I need to pass in here? When should I be using CUDA, and how do I use CUDA? and a lot of stuff like that. So it's never going to give us perfect answers. It's going to give us samples that could work, providing we could figure out the rest. And that's not too bad, I guess. So I guess the short answer there is obviously this isn't going to replace coders. It's just too much, I think. There's a lot more it needs to learn about how to, with a lot of this stuff, there's just often prerequisites that it doesn't quite address. And how could it? This would be a huge article to fully address all this stuff. So it's really good at giving you quick answers and kind of pointing you in the right direction. But I don't think it's ever going to write code that, unless you get lucky, I guess, that's going to work perfect for your situation. But I really like that it's getting us in the right direction quite quickly. So I think I'll find this quite helpful along with my coding stuff during the day. And a lot of times I'll probably use this over Google, as like I was complaining about earlier. Google just seems to give a lot of really bad results, especially when it starts parsing Stack Overflow. And maybe that's why ChatGPT is actually a little better than Google, because I heard Stack Overflow blocked ChatGPT, which was probably to their advantage. Stack Overflow is just full of too many trolls, really, to be that useful. Is really the truth, and it's really hard to manage. There's To be back on the topic of Stack Overflow versus this for a second. There's a lot of new people on Stack Overflow that do ask really ridiculous questions, and they kind of do need put in their place a little bit. I would say, at least some of them. But just the way that it's done is not good. It's way better to have an AI at least be polite than some human just spewing their nonsense all the time at you. So I do like this Chat GPT. I think it gets a pass, and that overall seems pretty good, from what I've experienced and seen so far. It's definitely an advancement, and geez, I'm just really glad that I can't express how glad I am that Stack Overflow blocked it for their own sake. I think this would be a lot worse if it were pulling from Stack Overflow. I really do think that, as it's just hard to know what answers from Stack Overflow are actually good most of the time. Too many trolls. Anyway, that's all speculation, but yeah, I'm going to use this more and play around with it more. It does seem to be somewhat useful for real work, and I think if you're deep in the subject, like if you're, for example, if I was an expert with physics, I probably won't need much of this stuff. But if I'm just getting started with anything, it seems like it's pretty good at pointing you in the right direction and really getting you going, at least so you don't stay stuck. And at least okay, I don't understand this, I need to go read it. Sometimes it provides you links, which is super nice. Why can't I pull these back up? It does crash some, so that's kind of annoying. I seem to have lost these chats all of a sudden for I don't know why. Maybe I just need to refresh. Yeah, okay. Because might want to go back to this and be like, okay, and ask follow-up questions like extract vertices and indices and texture chords with ASIMP 3D model file. Let's see what it comes up with this. Let's see if it, there's some answers out there. Yeah, you bring in the importer, scene, post-process, create the importer object. Very nice. Triangulate, flip UVs. That's debatable whether you want to do that or not. Okay, iterate through the meshes. Very nice. Yeah, this is pretty good. It is probably just pulling this code off of like Learn OpenGL or something, or one of the sample code files in ASIMP, but still, it's not too bad. It does in general give you the right steps. You got to go through all the meshes and get all the stuff. Now let's see what it's doing here. So for loop. So go through a mesh, for loop through that one's vertices, faces, texture chords. Now it's not exactly, okay, yeah, I guess it's telling you store the texture coordinates in your own data structure, store in your own data structure. And that's fine. That's generally what people do. I think that's mainly what I do in my code, except my code is a lot more robust and goes through all sorts of recursive stuff and does some special caching things. But still, this would basically get the job done as long as you could figure out how to store in your own structures, which is really not hard if you're half decent with C++. You could probably figure that out. But also, it doesn't really go into detail about when you would want to flip UVs or not, because I think it depends how you're going to be rendering. And yeah, that's not too bad. It's not too bad. Overall, I would say this is good. All right, so I also asked it when should I use CUDA for physics cooking. Now I kind of already knew the answer, but I wanted to see how it would respond. and it basically gives us a good answer. It tells us what CUDA is, and it tells us that it uses the GPU to perform highly parallelizable tasks for much faster processing, and it says it's often used for cooking. Process of pre-processing and optimizing collusion geometry, which is, probably what we want to do if we want it to go fast. Now, we're going to pre-bake in our situation, so not necessarily going to matter a ton, but still be nice. Might as well optimize it. But you do have to, and it tells you have to have a CUDA enabled GPU. And now we can go, how do I use CUDA for physics geometry cooking? Let's see what it says. Sure that you have the drivers. You need to have the toolkit, very good, and the physics SDK installed. Write a CUDA kernel function, perform cooking on the GPU. This function should take input geometry as arguments and return the cooked geometry. Well, it's getting way ahead of me here, but here we go. It's even given us some decent code. Call the CUDA kernel function from your C++ code. Transfer data from GPU to CPU. Okay, so then it's given us some decent functions. So yeah, this should give me a good jump start on this whole operation. Definitely gonna be faster than Googling, it seems like. So my goodness, I'm just kind of falling in love with this chat GPT at this point. I mean, it's not the end all be all or anything like that, but it definitely feels nicer than most Google searches or search engine searches for this coding stuff. So I find that to be pretty awesome. All right, let me know what you guys think down below. I appreciate you guys and everyone who supports me. See you in the next one. Peace out.